In this video lecture, we will look at what are Kepler's law. This is very important and interesting part of this chapter. It is my personal favorite. So I hope you will enjoy this video. So without wasting any more time, we'll start with the lecture. Before looking at Kepler's law, there's one thing that you need to understand. First, we will look at what is an ellipse. What is an ellipse? To understand this, I'll draw a diagram for you. If you observe this shape is an ellipse. I'll draw some axis for this. Fine. So now we'll start with what is an ellipse. I'll explain this with the help of this diagram. Let's say this is your x-axis and this is y-axis. The point of intersection of both the axes is taken as the origin itself. इतना तो आपको मालूम है. Now for this particular ellipse, this is known as a horizontal ellipse. This is known as a horizontal ellipse. Now in this case, the x-axis is taken as the major axis and the y-axis will be the minor axis. Now it is very much clear why x-axis is the major axis, because if you observe in the diagram, the length of the axis which lies on the x-axis has a greater length. A shape like this is known as an ellipse. इसको बहुत ज़्यादा डिटेल में हम डिस्कस नहीं करेंगे because it is not required at your level. But there is a special property of an ellipse that you should understand, and the property is, if you consider any point on the ellipse, for example, if I say that at this position there is a point which I mark as A. So if you consider this point, always remember when we talk about an ellipse has two special points which are known as focus. Which are known as focus. For example, if the first focus is at this position, let's say this is f1. So by symmetry on the exactly on the opposite side, you will have another point which I will mark as f2. Both these points are known as focus of an ellipse. Now, for example, if you talk about a circle, you know that the center is the special point because every point on the circle is at equal distance from the center, which is your radius. Similarly, when we talk about an ellipse, the special points are the focus. Fine. So the special property is, if you add the distance of a point on an ellipse from the focus, it will always give you the same value. For example, if I join A and the focus f2, and if I join f1 with A. So if I say the distance f1A plus the distance f2A, it will always give you a constant value. Let's say alpha. This is your constant. This value will be a constant value. Now if I consider another point, I'll use different color for this. Let's say there's another point on the ellipse which I will mark as B. Now if I join f1 with B and f2 with B, so the property is the distance f1b plus the distance f2b will be again a constant, that is alpha. In both the cases, the sum of the distances of a point on the ellipse from the focus will give you the same value. This is the special property of an ellipse. Now you need to remember, focus is a singular word. If you talk about any one focus at a time, so we use the word focus. But if you talk about both the focus at the same time, we use foci. This is plural. This is all about ellipse that you need to understand. I have not given you proper definition, but the property that is useful that you should remember, I have explained it. I hope this is clear to you. Now we will look at what are Kepler's law. This person is Johannes Kepler. Now, before discussing about the laws given by Kepler, I'll just discuss the story about Kepler. Kepler was the assistant of a scientist whose name was Tycho Brahe. Now, Kepler is known for his work on the planetary motion. Throughout his life, he made observations about the motions of planets, and then he ended up with three laws, which now we refer to as Kepler's law. The laws that are given by Kepler's are very important because the laws that he gave are all based on the observations that he made throughout his life. Because at that time we didn't have much technology, so everything is based on the observation done by Kepler. So we'll first discuss about the first law, which is also known as law of orbit. According to the first law, planets revolve planets revolve around the sun in an elliptical orbit in an elliptical orbit with the sun at one of the foci with the sun at one of the foci. Now what does this mean? And if you observe this law, it has two parts. If you observe the first part, it says planets revolve around the sun in an elliptical orbit. Now, I hope elliptical orbit is clear to you. The shape of the orbit of any planet which revolves around the sun is elliptical because see people before Kepler they just assume that the orbits of all the planet is circular. Now the reason behind this was because if you look at Earth, the orbit of Earth is nearly a circle. If you say this is the sun and if this is Earth, if you observe the orbit of the Earth is nearly circle, you need to focus on this. I'm not using the word circular. It is nearly a circular orbit. So what people did before Kepler, they just assumed that for all the planet the orbit is circular. But Kepler gave the exact information about this. He said that the orbit is elliptical and not circular. And the second part of this law says it tells you the position of the sun. It says that the sun is always at any one of the foci. Look at this. I have drawn an ellipse for you. As we discussed earlier, when we talk about an ellipse, it has 2 points, two special points, which are known as the focus, let's say F1 and F2. According to Kepler, if the planets revolve in an elliptical orbit, the sun will lie at any one of the foci. The sun can be at F1 or it can be at F2. So I hope this is clear to you. This law is very easy. It is also known as law of orbit. Law of orbit. Moving on to the next. According to Kepler, he said planets sweep out planets sweeps out equal areas in equal intervals of time equal intervals of time. Now see, this law is very important. To explain this, again I'll draw an ellipse like this. We know that the sun is at any one of the foci, so I'll say that the sun is at this position. Assume that the sun is at this position. Let's say let's say the planet is at this position. Let's say the position of the planet is at point A. Now, according to Kepler, the planet will sweep out equal areas in equal interval of time. So, what it means for this, what we need to do is if I mark the position of the sun as S, so what I will do, I will join the sun and the planet using a line. Now, let's say if I take the time as 1 month, I will say that after 1 month, this planet is at this position. Let the position be represented by point B. Now if I join the sun and the planet at point B, so you can observe there is an area, this shaded region. If you measure the area, so let's say the area ASB, it is beta. It is nothing but a constant value. If you measure the area, let's say it turns out to be beta. Now if I consider the same planet but at different position, I'll say the planet is at this position now. Let's say the position is C. Now if I join sun and planet with this line, again I'll consider the time as 1 month. After 1 month, let's say the planet reaches at this position, which I will mark using capital D. Now, if I join the sun and the planet at this position, again you can observe an area, this shaded region. Now, if you measure the area of this region, area of DSC, it will again turn out to be beta, that is a constant. So, what it means, if you talk about in equal intervals of time, the planet will sweep out equal areas. Now, this is very important observation made by Kepler's. Also, from this law, you can understand that when we talk about the position of the planet at the far end, we can say the planet is moving slowest. The planet is moving the slowest, and when we talk about the near point of the planet, it is said that the planet is moving at a faster rate. Now, to understand why the velocity or the speed of the planet is different at different positions, we'll understand this when we talk about Newton's universal law of gravitation. For now, just remember when the planet is at the far end, it moves with a slower speed, but when it reaches the near point का मतलब है when it is near to the sun. For example, at this position, point C and point D are considered to be the near point. At the near point, the planet moves with a faster rate. I hope this is clear to you. Now moving on to the next law that was given by Kepler, which is also known as law of period. I use different ink for this. According to Kepler, the third law says square of the time period, square of the time period is directly proportional to cube of the mean distance. Cube of the mean distance. If you represent the law mathematically, so it is written as t square is directly proportional to r cube. I'll explain this to you again. If I draw the diagram, this is the ellipse, and let's say if the planet is at this position, which I mark as A. So first you need to understand what is time period. If I say the initial position of the planet is at A, so if this planet starts revolving around the sun, let's say the sun is at this position at any one of the foci, and when it reaches the initial point again after one revolution, so the time taken by planet to complete one revolution, it is referred to as time period. Time period is nothing but the amount of time taken by a planet to complete one revolution. I hope this is clear to you. Now, what do you understand by mean distance? For example, again consider this position. If you join the sun and the planet, let's say the distance is d1 at this position. If I say that the planet is at this position, let's say at point B. Now, if I join the distance, it will be a different value. Let's say the distance is d2. If the planet is at this position, let's say the position is point C. Now the distance is d3. So if you change the position of the planet, the distance between the planet and the sun will also change. So what we do, we calculate the mean. We calculate the mean of the distances. Now I hope you know how to find the mean. It is nothing but sum of observations upon total number of observation. So what you do, we will add all the distance like this, and you will divide it by the total number of observations. This is just an example. So I hope you are clear with what is mean distance. Now there is one more thing after this law. If you look at this relation, that is t square is directly proportional to r cube. So always remember, if you want to remove this proportionality sign, what we do, we introduce a constant. Now how to do this? This will be written as t square is equal to r cube. Now in place of this proportionality sign, I will introduce a constant. This k is a constant. If I shift this r cube on the other side, so I can say t square upon r cube is equal to a constant k. Now this equation is very important. We will use this when we discuss about Newton's universal law of gravitation. Just remember this from Kepler's third law, which says that the time period, square of the time period is directly proportional to the cube of the mean distance. From this we derive a relation which is t square upon r cube is equal to a constant k. Just remember this. I hope the laws are clear to you. They are very interesting. I find them interesting. Also, why Kepler's law are so important? Because people before Kepler had no idea about the exact motions of all the planets. Kepler was the first scientist who could give a proper explanation to the motion of any planet. Also, Kepler's law also helped Newton to propose his universal law of gravitation. The statements that I have written in this lecture are just for your understanding, but for your examination, you will learn the definitions from your book, because it is the rule that the definitions or statements given by scientists that are given in your books should be written as it is. So the statements that I have written, these are just for your understanding, but you will learn it from your book. So I hope this video was helpful to you. Make sure to subscribe to my channel and hit that like button. Till then, thank you for watching this video, and we'll meet in the next lecture.